Now we will learn about some properties of tangents. We do two properties of tangents, and the properties of tangents are in the form of theorems. Our first theorem: a tangent to a circle is perpendicular through the point of contact. A tangent of a circle is perpendicular to the point of contact. Here, look into the figure. There is a circle with center O. Then tangent is AB. You can see a tangent that touches the circle at the point P. So there is a circle with center O. Then AB is the tangent. Point of contact is P. Now you need to prove that OP perpendicular AB, or you need to prove that here at angle P a 90 degree is formed. That is what we have to prove. So we will start. Now there is a construction. I have joined a line from O that touches the tangent at AB. OQ is the line that I have drawn. It touches the circle at the point R. You can see that. So now there is a circle with center O, tangent AB, OP is the radius, OQ is the line drawn, and OQ touches the circle at R. Now we need to prove OP perpendicular to the tangent. We know that among all the line segments drawn from the center to the chord, the shortest one will be always the perpendicular one. So it is enough to prove that OP is the smallest line segment drawn from the center to AB. For that we are taking another line segment called OQ. So see here, OP is equal to OR. Reason: radii of the circle. Also OQ is equal to OR plus RQ. Look into the figure there. OQ is the line segment, that big line one. It can be splitted as OR plus RQ. But OQ is greater than OR, or OQ is greater than OR is same as OP. This implies OP is less than OQ. OP is less than OQ. It is only possible if OP is perpendicular to AB, hence the proof. So I hope the proof is clear to all. So there is a circle with center O. We need to prove that OP and the tangent, radius and the tangent are at 90 degrees. So we know a result from the smaller class, that is the 9th standard. You have learnt that among all the line segments joining from the center to the point on AB, perpendicular distance will be the shortest. So here we need to show that OP is the shortest line segment that can be drawn. For that we are taking another line segment OQ. We are drawing a line from O to Q. Then OP is equal to OR, radii of the circle. But OQ, you can split OQ as OR plus RQ. So definitely OQ is greater than OR. Instead of OR, I can write OP. Why? Because both of them are radii of the circle. Implies OP is less than OQ, or OP is the shortest distance that can be drawn. Hence the proof. Second theorem. Length of the two tangents from an external points are equal. Length of the two tangents from an external points are equal. So there is a circle given here with center O and radius r. Then there is a point A outside, external point, exterior point. From A to the circle, two tangents are drawn. What are the name of those two tangents? AP and AQ. You need to prove that AP is equal to AQ. Since all these are theorems, you know that there is a format to write given to prove construction, proof and all. So what is given here? Consider a circle with center O and radius R. A is the exterior point or external point. AP and AQ are the two tangents from A. To prove AP is equal to AQ. Now before going to write the proof, there is small constructions to be done. From A to O, I am just drawing a line. Then P to O is also drawn. O to Q is also drawn. From the previous theorem, we know that OP, that is a radius, is perpendicular to the tangent. So here also OQ, which is a radius, is perpendicular to the tangent AQ. So when I drew the line over here, you can see two triangles are formed. What is the first triangle? AOP. And the second triangle AOQ. So we will start the proof. So what are the names of the triangles we should start with? Consider triangle AOP and triangle AOQ. What can you say about OP and OQ? OP and OQ are equal. What is the reason? Radii. Then angle P is equal to angle Q is equal to 90 degree. Reason? Radius is perpendicular to the tangent. OA equals OA, common side. Then by which criteria? By RHS congruence criteria, you can say that triangle AOP congruent triangle AOQ. If these two triangles are congruent, AP will be equal to AQ. Reason? CP, CT. Congruent parts of, corresponding parts of congruent triangles. Hence the proof. So construction part was, I drew a line from A to O. Then I joined O to P, O to Q. So two triangles are formed and we used the RHS congruence criteria to prove that this triangle and this triangle are equal. If those two triangles are equal, then AP and AQ will be equal by CP, CT. Hence the proof. Third theorem. Tangents drawn at the ends of the diameter are parallel. So you can see a circle there. What are the names of the tangents? LM is one tangent, PQ is another tangent. We need to prove that LM and PQ are parallel and AB is the diameter of the circle. So given, consider circle with center O and radius R. PQ and LM are the tangents. We need to prove LM parallel PQ. So shall we start the proof? Okay. OB is perpendicular to PQ. Why is OB perpendicular to PQ? OB is the radius of the circle. It is perpendicular to the tangent. If OB is perpendicular to PQ, then you can definitely say that AB is also perpendicular to PQ. This implies angle PBA or angle B equals 90 degree. Okay. Then similarly OA perpendicular LM. OA is the radius of the circle. Radius is perpendicular to tangent. So definitely you can say AB or BA is perpendicular to LM. Implies which angle will be equal to 90 degree? Angle A. MAB equals 90 degree. So now you are having angle PBA 90 degree, angle MAB 90 degree. Check in this figure, angle A 90, angle B 90. If alternate interior angles are equal, the lines are parallel. Therefore, LM parallel PQ. Hence the proof. So here we learned 3 theorems. All those 3 theorems are basically the properties of tangents. What all were the properties of tangents? What was the first theorem that you learned? Radius of the circle and the point of contact at the tangent are perpendicular. Radius perpendicular to the tangent. What was the second property that you learned? If there is an external point and if there are tangents drawn, both the tangents will be of equal length. And what was the third one? If there are tangents at on the either sides of the diameter of a circle, both the tangents will be parallel. These are the 3 properties that you learned about tangents. And what are tangents? Line drawn on the circle. There is one more characteristic property there. The line that touches the circle at one single point is known as the tangent of the circle. Children, write and learn the theorem. It is very, very important, all these things.